Welcome to this course on Characterization of Construction Materials. I am Piyush Chausali, faculty in Building Technology and Construction Management Division of Civil Engineering Department at IIT Madras. Have you ever wondered why some construction materials last long? We have examples of construction materials lasting for more than 1000 years, but also we have many cases of their unexpected failure after short exposure period. So in this course we would like to understand structure performance relationship. What is in the structure of these materials that influences the performance? So by using various characterization tools, we will be able to monitor and measure properties at different time and length scales. The main objective of this course will be to use the commonly used characterization techniques in material science discipline to probe construction materials such as concrete. Once underlying principle of a technique is known, it can tell us about physico-chemical properties that govern the properties of a specific material. Another key aspect of the use of characterization tool lies in understanding the cause of materials failure. By better understanding this structure performance relationship, we can determine the cause of the failure of construction materials such as concrete. So by knowing all the characterization techniques, we will be able to design stronger and durable concrete. So at the end of the course, you will be able to treat concrete in the same way as doctor treats a disease.
I am Vaishnav. I am a PhD scholar with the Building Technology and Construction Management Division in the Civil Engineering Department of IIT Madras. I will be one of the TAs handling this course. Characterization techniques will help us in understanding the processes and the underlying mechanism that govern these processes. For example, if you want to study the hydration characteristics of any cementitious binding systems, we can use techniques like calorimetry to determine the kinetics, that is the rate at which the reaction proceeds. Further, if we want a better understanding of what exactly happens in the hydration reactions, we can use techniques like X-ray diffraction and thermogravimetric analysis, which will help us to identify the hydration products that are formed. These techniques are commonly used in identifying and quantifying the different phases that are present in the system. Every characterization techniques has its own advantages and limitations. Concluding or interpreting the results just based on one characterization technique may not be accurate. For example, when we use TGA to determine the amount of ettringite or CSH, since they have overlapping peaks, distinguishing these two phases becomes difficult. Whereas when we use XRD, crystalline phases like ettringite can be easily identified, whereas amorphous phases like CSH may not be easily distinguished using this technique. So just by using one of the techniques, it is difficult to identify or quantify these components, whereas when we use both these techniques, they supplement each other and help us in quantifying the different phases.
Hi, I am Swati, PhD research scholar at Civil Engineering Department of IIT Madras. I do research on the challenges in the area of conservation of heritage structures. During restoration, we use new materials, let it be stone, bricks, mortars or coatings, but they must be compatible with the original historical material. But the problem is we really don't know what they are made of or how they are made. The characterization techniques which we learn in this course will help us or give us an insight into the properties of these materials. We can even trace back the raw materials and manufacturing processes. It's actually pretty exciting to see what our ancestors has done to have these marvelous monuments of today using these modern engineering tools now. The students who take up this course is expected to have a good background on the concepts of physics and basic material science, like how the wave propagates, the properties of electromagnetic spectrum, and some common ideas on the materials of construction and their properties. This is a good course which enables us to find the causes for the major problems we see in material science.
Hello everybody, I am Manu Santhanam, professor from the Department of Civil Engineering at IIT Madras, and I will be co-teaching this course on characterization of construction materials along with my colleague Professor Piyush Chausali. So this course will enable you understand the characteristics of materials from the fundamental microstructural viewpoint with the help of several techniques that are from the realm of chemistry and material science. This course focuses primarily on cement and concrete, and the course will include the following techniques. So the techniques that we will cover in this course will include calorimetry, X-ray diffraction, thermal analysis, surface properties, microscopy, both optical and scanning electron microscopy, which will be followed by a discussion on image analysis, that is how to interpret the images that you get from microscopy techniques. This will be followed by a discussion of spectroscopic techniques that have a vast range of possibilities when applied to construction materials. And then finally, we will round off the course with a discussion of mercury intrusion porosimetry and finally impedance analysis and ultrasonic methods. Now, you can see that we have selected a vast array of techniques. The course will primarily focus on trying to understand the scientific principles of the processes that are involved in these techniques. We will learn about the physics of these techniques and look at their applications to cement and concrete science. There will also be examples from other construction materials, but primarily we will focus on cement and concrete science. What you will understand at the end of this course is how to decide on what technique suits the specific problem that you are trying to address. What are the possible limitations of these techniques and what kind of answers can you expect to get from these techniques when you study construction materials. This course will be useful for students and researchers in concrete technology, because without appropriate characterization techniques you really cannot get an answer to understanding the real behavior of cement and concrete. The main challenge as far as understanding the role of these techniques is concerned is how to interpret the results in order to link it with the overall concrete performance. For example, we understand that concrete strength is a very important property that we measure all the time in the laboratory. But what are the parameters microstructurally that contribute to this strength? One example for instance is porosity. How do you determine the porosity? There are several techniques to do that at different levels. The issue is how do we relate the story at these different levels and link it to the overall performance of the concrete. So that is what this course will help you understand, what technique to use and when to use it and what kind of information will the technique actually give. Now, apart from researchers in cement and concrete technology, this course may also benefit several practicing civil engineers who would like to try and understand a little bit better the kind of issues associated with fundamental material level performance, which will affect the overall performance of the structure in the long run. Very often, at least even if you are not directly involved in understanding these principles and doing these techniques on your own, you should at least know how to approach the problem when you actually see cases of material performance in the field that are not expected. So, we hope that this course is going to be very useful for all of you who are attending this course, and you will be able to apply the sciences that we discuss in this course successfully in your research studies and your practice with cement and concrete. Thank you.